Welcome to our exploration of carbonyl compounds. A carbonyl group is a functional group characterized by a carbon atom double bonded to an oxygen atom, C equals O. This group is essential in organic chemistry, forming the backbone of many important compounds. Today, we will focus on two major classes of carbonyl compounds, aldehydes and ketones. Let's start with aldehydes. An aldehyde is defined as a compound that contains a carbonyl group located at the end of the carbon chain. On the screen, you can see some examples of aldehydes: methanol, which is the simplest aldehyde; ethanol, also known as acetaldehyde; and propanol, which has a 3-carbon chain. Lastly, we have 2-methylbutanol, which illustrates how branching can occur in aldehyde structures. Now, let's introduce ketones. A ketone is a compound that features a carbonyl group located within the carbon chain, specifically between 2 carbon atoms. On the screen, you can see examples of ketones: propanone, commonly known as acetone; butanone, which has a 4-carbon chain; and pentan 3,1, showcasing the diversity of ketone structures. In organic chemistry, differentiating between aldehydes and ketones is crucial for identifying their unique chemical properties. In this video, we will use 5 simple tests: 2,4-DNP, also known as Brady's reagent, Tollin's reagent, Fehling's solution, potassium permanganate, and the iodoform test, to distinguish between these two groups of compounds. The first test is the 2.4-DNP test, also known as Brady's reagent test. In the left test tube, you can see the formation of an orange precipitate, which indicates a positive result. The right test tube shows no visible change, which means the test is negative. The second test is Tollins's reagent test. The left test tube shows a characteristic silver mirror forming on the inner surface, confirming the presence of an aldehyde. In contrast, the right test tube remains clear, indicating a negative result for a ketone. The third test is Fehling's solution test. The left test tube contains a brick red precipitate, which is a positive result for aldehyde. The right test tube remains blue, indicating a negative result for ketone. The fourth test involves potassium permanganate. The left test tube has turned colorless after reacting, confirming a positive test for aldehyde. The right test tube stays purple, indicating a negative result for ketone. The fifth test is the iodoform test. This test reveals that ethanol tests positive due to its structure containing a methyl group attached to the carbonyl carbon. For ketones, only those that have a methyl group adjacent to the carbonyl, known as methyl ketones, will produce a positive result, resulting in the formation of the yellow iodoform precipitate. The first test tube shows how a positive result will look when a yellow precipitate forms, confirming the presence of the methyl group adjacent to the carbonyl group. The second test tube shows a negative result.